Hello students. Okay, please sit down. So, the topic of our today's lessons is electrolysis of molten and aqueous ionic compounds. In this lesson, you will be able to describe how molten ionic compounds are electrolyzed using ideas about movement of ions.
You should be able to explain how aqueous ionic compounds are electrolyzed and write equations for the reaction at the anode and the cathode and the full overall equation.
And also you should be able to explain the terms anode, cathode, electrolyte and electrolysis.
Our essential question for today's lesson is: how does matter undergo changes and how do we use chemical equations? Okay, so that's our overriding essential question. But to start with, ladies and gentlemen, you are going to be given a question or an answer. It is your job to find the correct question or answer for the information that you have on your piece of paper. You're only going to have 2 minutes to do this, so make sure that you read your piece of paper very carefully, and then you're going to move around the classroom and should we say that?
Okay.
And you're going to move around the classroom to find the person. I have got an answer or a question here, so you might want to ask me as well. Ready? Go.
So you should find
Off you
the
go.
pairs. Your answer is right. Okay. Okay.
Once you've found your pair, remain in your pairs together, please.
Okay.
Stay with your partner that you have found. Don't go anywhere. Keep them close. They're your new best friend.
Yes. So you. Yes. You should. So please sit together with your pairs.
With the person who you have found your answer or question with, you need to sit down with that person. You're going to join another group, so don't worry, you won't be
Behind here you can join to Nurjan and Ayhan. Okay. The next task, you should write the electrolysis of molten ionic compounds. So first, fill out the equation worksheet for the ionic compound you have on your desk. Once you have finished, move to another table to the complete equations. Complete all 5 equation boxes for ionic compounds, and after you should check your answer.
Students must write equations describing the dissociation of molten ionic compounds, reaction at the anode and reaction at the cathode, and overall equation. When they finish the electrolysis reactions for the one ionic compound, they move to another desk to do the same things for other molten ionic compound.
Okay, once you have finished, you can move around to the next table to find another salt. So you've got another salt just behind you. You want to move to that table because
During the task, teacher walks around the class and checks students' answer, but teacher should not correct every single mistake. because at the second part of the task, students will check and assess themselves.
There's one at the back. We're liking the work this morning, ladies and gentlemen. Nice.
And now you balance oxygen, yes? Yes. Oh, here is the solid. Are you sure? Check. Count the number of oxygen. 4, here, 15, 16. Now you're right. Now you're answering. Now you should count. Which oxidation number phosphorus there? Which oxidation number was the phosphorus? Okay, there should be produced P2O5 and O2. So your answers should be the same. Just check each other.
Front one, you two want to move down to the back one? You done that one yet? Good, excellent. And this one is just quite easy.
So now you should check yourself. On your desk you have answer sheet and also the self-assessment form. There you should write the formula of your ionic compound, and while checking your work, you should put plus if your answer is correct, or and you should put minus if your answer is incorrect. Now please check your work. Yes. Yes, you should write the formula of the ionic compound, and there's the answers. Yes? Yeah. So, if you wrote the substitution reaction is correct, you put plus. Yes. Please write your names on your self-assessment form. Your names. Please put these labels, yes? Plus and minus there. Okay? So if your dissociation equation...
Make sure your names are on the sheet, please, ladies and gentlemen. Miss Nazgul is going to come round and collect in your answers. Ladies, you finished? Yes. Good. Okay, right, ladies and gentlemen. So we have just spoken about molten ionic compounds. Okay? The next part of the lesson we're going to be looking at aqueous ionic solutions, okay, and the difference between electrolysis of molten ionic compounds and aqueous ionic solutions, okay. On the board there are 4 questions that we would like you to think about, okay. There is also some information here on the board as well that you might want to use about reactivity series. What we would like you to do is to read these 4 questions and to discuss them with the person next to you, okay? Try to decide on an answer for these 4 questions. We'll give that about 3 or 4 minutes. Ready? Go. So we've got NaCl, okay? But it's an aqueous solution. What's an aqueous solution?
We can go closer and read the question.
That means it's dissolved in water. Okay? So what's the dissociation? Can you write the dissociation equation for water?
Which ions will be attracted to the anode and which will be attracted to the cathode?
Okay? Now, we've got NaCl.
Chloride to the anode, natrium, hydrogen, sodium, move to the cathode, and also hydrogen and hydroxide. Will move to the hydroxide will be one of the ionic compounds that is present in aqueous hydroxide will be one of the ionic
As a solution, yes? It's a solution. Okay?
We're now talking about
Give me the list of
sodium,
sodium plus
okay. So there are 4
chloride,
chloride.
chloride,
and 2 from the ion.
yeah, hydrogen.
You understand? You understand?
So please write into the equation solution of water.
And it's a anode.
Which ones are attracted? Which ones are attracted to the
Okay, what's another name for the sodium ion?
hydroxide minus
What generally? Think about positive metal.
Okay? Okay. So please give me the answer for the first question. First yes. Ions are present on the solution of sodium chloride. Ions, sodium,
Sorry, ions,
chlorides.
okay, and 2 ions is most likely to be produced by ions.
Okay. After you have to write the ions. Which ion will move to the cathode and which ion
Okay, because the reactive is more likely which 2 ions are going to go to this hydrogen.
What? Hydrogen. Hydrogen. Okay. Third question about
To the anode. Yes. Which is just talk about the moving stuff. Okay. We'll make it.
Teacher displays questions on the board in front of the class with information about the reactivity series of metals and of the other ions. Students read the questions and discuss in pairs possible answers to this question. During the task, teachers should walk around the classroom and help to the discussion move along. If students are talking about wrong things, teachers should get conversation back in the right way. Teacher just facilitates the answers and encourage students to answer correctly, but the correct answer should come from the students.
What is the answer from the question? Sodium? Why?
Charge from the electron. Because he's outside the reactor, there's no electrons.
Then anything else is left in there.
Which of the hydrogen?
Sorry?
Is sodium is more reactive?
Yes.
Why?
Yes. Okay, should we go back? Sorry?
Already discussed all of the questions. Because hydroxide is reacting with
Less reactive than sodium. We're going to ask you the answers for these questions now. So question number 1. At the back, could you tell me which ions are present in an aqueous solution of an ionic compound of NaCl? Which 4 ions are present? At the back, please.
H, hydrogen, OH, nitrogen and chloride.
Okay, fantastic. OH, what do we call that in English? Hydroxide. So, what are the 4 again? Hydrogen, ion. At the back, please. Sorry, ladies and gentlemen, at the back. Nitrate. What's the name of nitrate in English? Sodium ion and chloride ion. Fantastic. Okay. At the front here, which ions will be attracted to the anode and which will be attracted to the cathode?
Chlorine will be attracted to the anode and sodium will be attracted to the cathode.
Okay. What about the hydrogen and the hydroxide?
Hydrogen is going to attract to the cathode, and hydroxide is going to be attracted to the anode.
Fantastic.
Okay.
Very, very nice.
And which ions as a cathode is more likely to be reduced? Okay, again.
hydrogen because sodium is going to react with hydroxide, so hydrogen will more likely to be reduced.
Okay.
Okay. Could you just tell me which is more reactive, sodium or hydrogen? Sodium. Okay, fantastic. That's why. Good. Excellent. Fantastic. Okay. And question number 4. At the anode, which of the 2 ions is more likely to be oxidized and why?
Chloride ions will be oxidizing because hydroxide will be reacted with sodium.
And what will it form? Well, when the hydroxide reacts with the sodium, what is that going to make?
Sodium hydroxide.
Fantastic. Excellent. Thank you.
Okay, now we'll talk about the writing of Electrolysis equations for molten ionic compounds aqueous solution. Let's try to write the equation for zinc nitrate. Who wants the formula of zinc nitrate? Ion, please.
Drink NO3 2 times.
Okay. Can you write for me the formula of zinc nitrate? Okay. What will be produced during the dissociation aqueous solution. As we mentioned before, there are 4 ions in aqueous solution. Who can tell me which are 4 another ions? Oh, 2 another ions.
2 another ions are zinc and NO3 ions.
Okay, we wrote the zinc and NO3 ions, and we mentioned that it's an aqueous solution. Yes? And what ions are present in aqueous solutions also? Hydrogen and hydroxide ions. Okay, hydrogen and also hydroxide ions. Well, the processes which are occur at the electrodes. We have 2 electrodes, cathode and anode. Which ions will attract to the cathode? Zinc and hydrogen. Okay. And how do you think zinc, is it reactive, medium reactive or non-reactive metal? It's medium reactive metal. Okay. So what will be produced as a cathode? Who can rewrite the equation for me? What should we add to this equation?
Hydroxide 2 times.
Yes.
Robert, can you come to the blackboard and show? What's the charge of hydrogen?
Hydrogen.
Okay, well done. Now let's talk about anode. Which ions will be attracted to the anode?
NO3.
Hydroxide and hydroxide and also NO3 minus. Okay. Now look at the blackboard to the presentation and tell me which ion will be oxidized at the anode. What do you think?
Hydroxide.
Hydroxide. Okay. Can you come and write the equation? That's correct. Please sit down. How many reactions occurs at the cathode? 2 reactions. And how many electrons are gained during these 2 reactions? 4 electrons. And at the anode? How many electrons is there?
Also
4 electrons. Is this electrons balanced?
Yes.
Okay. Now, please write for me the ionic equation. Okay. Can you write it? You can write there. Okay. Okay. Please sit down. Okay. We have 2 ions, hydroxide ion and hydrogen ions. What will produce between hydroxide and hydrogen ions? Water. How many water molecules? 2 water molecules. Okay. Two hydrogen, okay. And what molecule can we can cancel? Water. What molecules? Two water molecules and there? Two water molecules. Okay. Now please write the overall equation for this reaction on your copy books. Okay, let's look at these reactions. What is wrong with this reaction?
She forgot water molecules.
Water molecules and
Acid.
okay. Let's bring this side of the equation and write correctly. And also, inside and right here. Who can tell?
There is NO3 near H.
So there also will produce nitric acid, yes? And zinc. And zinc. Okay. Please sit down. Okay, now you're gonna do practical for the aqueous solution of ionic compounds. Now please divide into 3 groups and come to the electrolysis cell.
There are 2 at the back and 1 at the front.
Okay, now you should choose your solution. Your task is to find solution in which aqueous solution hydrogen will produce as a cathode.
Is it potassium iodide?
Yes. Okay, please start your work. Okay, now what is your task? So your metal should be reactive or less reactive. Okay, which metal?
This one.
Yeah. Okay. Okay, you can start. Please choose a solution. Write this sentence and find a solution. And what is the solution? Okay. Okay. Start your work and please write your observations for this practical worksheet. Okay. Let's plug this teacher.
Yeah, but no, the piece of wood. Why is it in there?
Because there should be one there.
Yes.
Oh, it fell in.
Okay, so what do you want to do with cathode?
Now, please, what do you observe there? So what is happening there?
In ions we can see ionized because it's stone, and in hydrogen we can see little bubbles in gases.
Okay. Yes. Okay.
In hydrogen,
Okay. Now please you write your observations there and write the equations for this reaction.
Okay, focus on the equations as well, please. Make sure we get that done. Get a nice diagram. That's what groups are going. Yes?
Now when you present your practical work, you should show that. Yeah, because you said that there was you should show to another students that's your observation.
Make sure your observations are written down. That's really important.
Okay, please write your observations there. And also you should draw the drive diagram. So you should show the bubble, yes, and the anode and metal which go in there.
Okay. How many iodines do we have here? How many iodines do we have here? Two. Okay. Now, what are you missing here? You've got potassium here, but you don't have one here. How many? Okay. So what? 2 potassium ions or?
Now you should present your practical work to another student. Yeah, your equation is correct. And now, when another student comes here, you should explain your practical work, yes? So you should start with observation. You can switch on to the cell, yes? And this shows them this equation and start with your observations. Practical work. Now, if you finish, please come to this group. So every group will present their practical work, will explain to another group, and another group should assess. They should write down 2 things that you like about this group work and 1 thing that they need to improve. So you should think about the explanations, equations, quality of diagrams. Okay?
Okay, do you want to come up to the front? Bring a pen with you. It's very important that you bring a pen.
So we have electrolyte zinc sulfide, and in our observation we got this. In anode, bubbles come from an anode, and in cathode, here is pieces of metals. So bubbles means that it is oxygen.
And the pieces of metal is zinc. Zinc sulfate dissociates to zinc ion and sulfate ions. At the cathode will be produced zinc and hydrogen, and the anode will be produced only oxygen.
So this is your overall equation.
Yes.
Okay, we can look to this diagram and
And here we can see that where pieces of metal magnetized to cathode and bubbles of oxygen magnetized to anode.
Okay, do you want to write your 2 stars on a wish, ladies and gentlemen? And then we will move to the next group. Let's get it done quickly, please. Thank you very much.
please put a sticker there.
Excellent, fantastic. Make sure that you're bringing your pen with you, please. You've got one.
Coming here.
Can you please once?
This is your group.
It's mine.
Okay.
Okay.
You need to have one and you need to have one. Okay.
Our group checked potassium iodide, and we can look at the experiment. Here in the anode we can see brown precipitation, and in the cathodes we can see little bubbles which are produced, and we know that in cathodes, in this reaction, cathodes produce hydrogen, and in anodes iodine. And we can see this balance equation here. In this reaction, hydrogen will go to the cathodes, iodine to the anodes, and we have potassium hydroxide
As a solution.
as a solution. Yes.
Okay.
Okay, fantastic. Can you write down your 2 stars and a wish, please? Thank you very much.
There can you see our diagram?
Copper sulfate, and at the observation we see that this red net is anode and this black is cathode, and this here we could see how gas will produce. There were lots of small bubbles, and here we can see brown and yellow things that says about the metal.
Can you show your cathode?
Turn it off before this. Take it out.
Take it out of your cathode.
You ready? Holding it?
Yeah. Let's see here.
It's a copper metal.
The copper. And dissociation equation is copper sulfate is dissociated to copper and sulfate. And in reaction we had copper and oxygen. So you can see our balanced equation, ionic equations over here. And this is our diagram that shows in cathode we have copper and in anode oxygen.
Okay, could you write your 2 stars and a wish down, please, ladies and gentlemen? Thank you very much. And then take a seat back in your seats.
let's make a conclusion. Let's make a reflection as a traffic light. So if you understand everything, please put green. If you have some questions, please put yellow. And if it was hard and you didn't understand nothing, please put red.
Okay, thank you very much, ladies and gentlemen, for your lesson, for the lesson today. It was very, very enjoyable for us. Have a good rest of the day. Thank you.
Thank you.